Hey, thanks for watching. Today we're going to talk about the optimizer. It's going to be a deeper dive into all the features in the optimizer. So to start off, I have this job here and I've already set the material templates. That's something you have to do previous to setting anything up in the optimizer. You have to set up your material templates to make sure that it's cutting properly. So I have this bank of cabinets here which I'm going to cut. You're going to want to set it so that your material's 90, well, depending on the size of your CNC machine. The one that we have is a 4x8. So as you can see, these parts are 98 inches long. So you want to make sure that it's going to fit on the machine and or split the cabinet in a way that it'll cover the sides of, it'll be able to fit on the machine. So if you, for this case, I'm going to make this 101 perhaps, we'll do it. Okay, so now you're going to go from the products tab over to the cut list, and you should be shifting back and forth to the cut list in order to properly check to see if your materials are coming out right. This is showing me as 3/4 or 19 millimeter MDF doors and 5/8 melamine for the rest. So let's just go ahead and optimize this. So here you set your material, you select the material that you want to optimize. If you go into these menus, it won't, somehow I wish it would be able to pick through, like you could set your drawer box parts and run that this way, but you can only do that through your material templates. So you have to select all parts, select it down here. I'm just going to run the white stuff. So then you go over to this little button here, and you can also say you would just want to run cabinet 1 and 5, you would write here 1, 5. So the comma indicates a separation. As you can see, if you hover on it, it explains. And then you can also do a dash. So if I wanted cabinet 1 through 5, it would only run cabinets 1 through 5. If I just want cabinet 5, you just type in 5, click enter. If you want, if you have separate rooms, you can write the R1 C5, which indicates room 1, cabinet 5. Hit enter. Of course, I only have one room, so it's not going to do that for me. So C5, or sorry, no C, just number 5. And sometimes it's got an N in front of it. So usually that's like a drawer bank. So it could be N5. And if you're trying to figure out which number you're looking at, you go to the products tab. Say I want to indicate I want to run this cabinet 5. It says right here number 5. Also, it'll say down here in the drop down menu what it is. Number 5 here. 1, 2, 3, 4, 5, 6. That's the number you're trying to indicate to filter it out. So we're going to run it all for the white melamine, and then we're going to click optimize. Pops up this box here, and from this point you can select multiple materials. So I could run both if I wanted to. In this case, I'm just going to run the one. Click OK. If you've already ran it once, it may say this material already exists. Would you like to overwrite? 9 times out of 10, you just want to click yes, overwrite it. So I've dragged it into the other window. So it'll pop up with a window like this. So for me, it popped into my other window. So this is the optimizer for Mozaik, and this is how everything in the production side of things works off of. From this menu, it's basically the same idea as Mozaik, where you start in this tab, you go over to this tab, and you go over to this tab, and then you just continue working your way across. So from these menus up here, you can open a new job. You can, so if you wanted to say new job, this would be a blank project. So this may come in handy if you want to just say cut one part, and you can name it whatever you want. Name it something, you can name it test job. And the customer, doesn't really matter. You can select your materials. You can also add new materials. It's basically going to give you exactly what you have here. but blank. So under the parts tab, it wouldn't have anything. So you can add parts yourself, customize the size, optimize it onto a sheet. That's good if you're cutting custom sizes and stuff like that. Handy that way. From this menu, you have open job. So in this case, if you wanted to just skip the whole part where you're running it from Mozaik, or say you're running it from an office and you've saved it and it's on an online database like OneDrive or something, you can have your operator open it from this menu as long as it's optimized from Mozaik. So you can open a job. You can also save a job. So once you've ran the parts, it's good practice to save the job just in case you're halfway done cutting and then you lose power or you accidentally close the window or something. Then you can reopen it. If you don't do that, then it's kind of a pain to go back and find the parts and figure out which parts you've already cut. If you save the job, you save yourself a lot of headache down the road. So I highly, highly recommend after you run the job, you save the job. If you don't save it, you could lose it. It could cause you some grief later. So I would encourage you to do that. Here's a list of jobs you've opened recently. You can email the job to help desk similar to what you do in Mozaik. You can export stuff to different menus. We have the label app included in here, so we don't need this whole part. Yeah, so that's basically it for that menu tab. Then you have the edit tab, which this you would use for, you wouldn't use this too much, but if you want to, copy and paste things, you can use this menu. Under the libraries tab, this is where you're going to be setting things up, like your CNC tooling library, your materials. Your materials aren't set up here. You can adjust them if you wanted to, but it's not really the right place to do it. You should do it in Mozaik, but it brings up the same menu. Your machines tab, this will bring up what kind of machine you have. This is how you set up which post processor you have. So here, let's just say we want to add a machine. You add a machine, you enter the new name for it, click OK. Then you're going to say it's a CNC machine. If it's a CNC machine, it could be just a table saw, and you'll be able to do your rip cuts and stuff on there. Nesting machine. So you wanted to make sure that it's a nesting machine. This way you click either, give you better yield off your material. You can set your pricing here as well. You can automatically have it cut the waste pieces. So you would select that, so it would automatically cut your scraps. Rotate the sheets on printouts, so this will rotate it on the actual printouts. That way it fits. Sometimes it'll fit better on a print sheet if you do that. Then you go to CNC, set up CNC. This is where you select your post processor. So we only have one CNC, therefore only one post processor. If you are first time set up, or you're setting up for the first time in Mozaik, contact Mozaik to get the post processor. Hopefully they have one already done. If they don't, you have to get one from them, and then you have to import it from here. So you import whatever file they send to you, dump that in. Make sure you do a few test runs with it, and don't just assume that it's perfect right off the bat. I usually like to set my Z height super high, like at 3 inches or something, and then run a few test runs to make sure the CNC is not going to crash or anything, but just to make sure that you want to do that. Short file names if you want to. You'll get a long file name if you don't select this, and it will be basically you'll get a short file name that will be about 6 characters long. So it's nice for that. If you leave it off, the file name will say the whole material. So my materials are pretty long, like it'll say 16 millimeter 555 because I'm using Uniboard Nova white melamine. if you have this whole file name plus sheet 1, run 1, whatever, it sometimes will get pretty long, so I like to make sure that's selected. It'll just say sheet 12, sheet, like it says here, sheet 12, or it'll say run 1, sheet 12, it'll say room 1, whatever. So it's a lot easier to kind of file through what you're looking at that way. It does put it into separate folders for the materials anyway, so I mean, you don't really need to know what the material is when you're selecting that, as long as you select the right folder. So if you if you select this number right here, the safe Z clearance, the distance that the Z is safe to wrap it at. So if you set this at 5 inches, the machine will go up 5 inches before it'll do a rapid move and move to the next drill operation or whatever. Plunge clearance is the rapid down to clearance. So it'll wrap it down, it'll go up 5 inches, it'll go over to where it needs to go, and this is the clearance that it'll wrap it down to. If you set it to 1 inch, it'll go down to 1 inch. Now this here, the Z0, is at the top of the material, because it'll be 1 inch off the top of the material. And then this one would be 1 inch off the top of the material. So if you have 5/8, it would be 1 inch and 5/8. If you select this one, it'll be 1 inch from the top of the material. So this indicates where you're referencing from. Are you referencing from the surface of the material? You have to then measure your material very accurately every time. Or are you going from the bottom of the material, aka the spoil board? This one is the more common and certainly the more preferred method, is to measure go from the bottom of the material. I guess there's some options or reasons in which you would want to go select this one, otherwise it wouldn't be an option, but I feel like this is the right choice. Then you don't have to be quite as critical for your material thickness. This guy here, Y0, so this is, are you locating it over here? Are you locating it, bottom left corner would be right here. Which way are you orienting your Z0? So basically, which way are you putting it against your stops? So for us, it's this corner here, and that Y is the long axis and the X is the short axis. For you, it may be this way, and then you may have the top left corner. Maybe it'll be this is the reference here, Z0. So yeah, your park position is where, at the end of a program, where do you want the machine to go? Do you want the head to go all the way over here? Do you want it to go over here? You can set that right here. Hold down setup is, so if you have screws that you want to hold down somewhere, you can set this here. Let's just drag this over. So it'll pop up this window. You can set the drill you're using, the depth. You basically set this right here if you're editing a hold down. So if you have a piece that you want to hold down, you can add, this operation to it right here. Don't use that hardly ever, but it is an option. Spoil board resurface. We actually have our own program for this, so I mean, you can set this up in Mozaik to do a resurface. You can set up the pattern in which it goes, the tool holder position, the depth that you want the spoil board to do. This is basically just creating a G-code program for you. We've done this in VCarve because it's easier to be more in control of what you're cutting, I guess, or the order and operations in which it's happening. So we don't use this, but it gives you an option, kind of nice. Flip sheet dowels. So if you have flip sheet dowel, or say you have flip side operations, which again highly discourage you from trying to get flip side operations because this is kind of a pain to set up, but Mozaik does have flip sheet dowel, so it'll drill a hole through the sheet on the edges. You can select where your holes go. You inset from the bottom or the top edge, and you can drill it into your spoil board. So you'll do the first operations, then you'll flip the whole sheet over, put your dowels in, drop it onto the dowels, and then it's technically located properly, so that you can do flip side operations. We have done this before, but like I said, it's way easier to do whatever you can do to avoid flip side operations, and or if you have a rabbet or something and the rabbet and the dado of the face is on opposite sides, just set yourself up with a router bit set and a router that you never change, so that you can do the machining. Usually it's a qualified tenon or something that you'll get flip side operations, but have a hand router that you can just route the proper side and then do everything else on the CNC way easier that way. So I would discourage you from doing this, but it is an option. You can set like a 5mm drill bit with some 5mm dowels and flip the sheet over. All right, so here's some good information on this too. Like I said, I don't recommend it, so I'm not going to go into it too much. Okay, so you basically have set up your CNC. That's how you set up the machine. Make sure you have this post processor and it's correct. Do a test run with a thing before you actually start trusting it. And even at the beginning, don't trust it right away. Give it 3-4 months before you really feel confident in it, because there's always bugs and stuff that you should keep an eye out for. If you have a multi-drill, you can select multi-drill here, and then your post-processor should pick up the rest of the things that need to happen in the G-code for it to work properly. I'm not going to save that. So you have machines, shapes, same thing that's in Mozaik. I don't ever use this because I like to make Mozaik do all the operations and stuff instead of doing any of this stuff in the optimizer. So CNC tooling, you'll be using this one a lot. This is how you set up your tool paths, your panel tool groups, your edge tool groups, and whatnot for that. So don't forget about this question mark here. There's always, if you have questions on something and you don't want to look up this video again, you can go through these question marks and it'll give you a pretty good, run through of what these things are. So as you can see for this one, you have, I'll go back to here, close all. So this is like our setup, but the setup for standard Mozaik, once you download it's pretty similar to this. So you have 1/8 down shear, which we only use when we're cutting doors. You set your diameter, your pass depth. If you set this at 0, it's just going to go no limit. Step over, so that's how much it's overpassing itself. I'll show you that real quick here. So step over, that's how much it's going into the next run when you're doing, say, a pocket or something. How much can it actually step over? So this would be the amount that it won't cut through. Step over, plunge depth. So plunge depth is the maximum depth for each plunge. So you're plunging, if you set the set a 1/16th, it won't plunge deeper than the 1/16th. It'll do a pass. Add for through cut, this would be, say if you're using a 3/8 compression, you would have a through amount for the through cut, or even for your like a 5mm drill, how much deeper would you go to do a through pass? And we have 30 thou for the 5mm drill. Now don't forget the spur on the top. If you have an automatic tool measuring machine, this probably won't account for that spur. So just to remember that. So let's go back. Let's go to 3/8 compression. So the 3/8 compression, your depth of pass. So how deep are you cutting? I have it set at 5/8. We like to do it in 2 passes so that it will clean up the dust better. It does do a lot better job. I know there's lots of different ways to clean the dust. We just haven't got into that where you can have, blowers on it, or you can get the cyclone attachment that goes on the thing. We tried that, but it's a little too much power for our our spindle to handle, so we took that off. Miter fold bit, so this will give you your angles. You can set up your where is it? Oh, sharp corners. So you can set your angle here for what the degrees are. This is your spindle speed, your feed rate, your plunge rate. So that's basically how you set up your tools. So get your tools set up something like this. And down here is the application too, I should mention. So if you have, for us, we have a 3/8 down shear, which we use for dados and rabbets and all that type of stuff, and also for CNC cut doors. The compression we use for cutout only. And then over here you have drills. So you have a drill and whatnot. So if you have, like, say you have a hole, say a 35 millimeter hole. If you don't have a 35 mil bit set up in your tool set, which is in this menu, it will automatically pick the dadoing bit to like dado or pocket out the center of a hole. So if you have a hole operation and it's too big for a certain drill bit that you have, it will automatically use the, like for us it'd be the down shear. Okay, so that's basically it for tool properties. We're going to go over to tool sets, and then so here we have different tools. What our tool sets is, we have an 8 tool machine, so it'll hold 8 tools. So we filled in all the tools we use. 5 millimeter drill for pins and all that. We got the down shear for dados. 20 mil because we use Titus pins, and then 3/8 compression for through cuts, and then you have quarter drill, so we use that for the back side of our drawer boxes. 8 millimeter drill for the, if we ever do holes for our hinges on the CNC, we'll use the 8 millimeter drill for that. 10 millimeter drill for if we're doing, we use they're like hammer in leg levelers, and we use a 10 millimeter drill to drill those holes. And then we have the miter fold bit. So that's how you you basically insert a tool. So you'd go over here, say I got a 1/8 down shear, I want to insert the tool, and then you move it up or down in the tool numbers to where you want it to be. And then once you have your tool number set up to what your CNC is, you're pretty much good to go. That's basically all this menu does. You can also copy the tool set and have different ones, like we have a door tool set, which we use for cutting doors. So that's how we set up our tool set for that. If you have this is how you set up panel tool groups. So it's a little bit backwards in that when you're setting up Mozaik, your doors in Mozaik, you have to come into the optimizer and set up your panel tool groups to set up or to have it work in Mozaik. This is the only time when you do it backwards. You have to go to the panel tool groups in the optimizer, set up whatever tools you're using, and then from that you go into the Mozaik and select that in your door libraries and stuff. So for us, the most common one would be the bevel, shaker bevel. Oh, that's a 2-piece. So here, I'll just zoom in here. So you have 3/4 inch material. You can, I believe you can change this to your grid. So you have 3/4 inch material that is showing on. If you select here, it'll let you pick. So you say, 5/8. I want it to reference 5/8. And then you'll get a 3D view and you can see what you've set up so far. Okay, so this isn't including the pocket. So if you have a shaker, like this is basically set up for a regular shaker door, but your pocket part is set up in the door library in Mozaik. But this is how you set up the different tools you want to, do an inside edge profile. So for this, you're going to be doing tools like this. So you drop in a tool, and to add a tool, you go here. So now I've added this tool here. I've also picked center, but I don't really want it on the center. I want it on the edge. And then you're going to offset it however you want. So I know this is a 2-inch bit. This is not the one I'm going to use. You don't want a pocket on this. Let's offset it 1 inch. Oh, it must be bigger than oh yes, that one's like 1.5. No, 1.25. So that's how you get it to where you want it to be exactly. So you're referencing, this is the exact line to where the style is. So if you want to have, say, a big bit go and hog out all the way around the inside edge, that's where you would select that. I'm going to delete that one because I don't use that. If you want to add another one, you go here, select through the tools, drop it in. As you can see, I have a 1/8 down shear. This guy here. This isn't the right one to be working with here, is it? Okay, so I think I messed that up when I added the big bit in there, so my offsets were a little screwed up. So this is how you really want it to be set up. So you have your bevel bit. So this is my 60-degree vortex bit, and you want it right centered, the same depth as the rest of all your tool passes. And I do that third in the tool order, and then I do another one a little bit deeper. So just like basically 10 thou deep, higher, so that's higher, and then this one's just a little bit deeper. So I tried to get rid of the that little corner issue that I was having. A lot of times when you're setting up sharp corners, you get a little bit of an issue in the corners, but we tried to fix it that way. Now, if you go to, so you got your sharp corner, I got a 1/8 bit that goes and cleans out the corner as close as it can get. And then I got my 3/8 down shear that hogs it out pretty good on the edge. Then I have a Mozaik. I set up a pocketing bit to go and pocket out the rest of this panel. So when you hit 3D here, it'll show you that I got a bevel. Bevel here. If you have to set up new tools, it's probably worth getting Mozaik to help you if it's not pre-built into here. They have a lot of vortex ones in here. So those are really helpful to find. So you can go, like, for instance, this guy here. I know you have to build your tool shape like this. So it's the same as the Mozaik thing there, but I know it's tricky to get it perfect. So I would recommend you get Mozaik training if you have a bit that's not pre-built into Mozaik, or just try to buy bits that are pre-built into Mozaik. That's probably the safest bet. So once you've set your panel tool group up, you can set up a bunch of different ones. They also have a bunch that are pre-built in here as well. So you can see these bits are all making different profiles. This guy's doing a little edge and then a round over, and then you got a big ball that comes and cleans out the panel side there. Then the edge tool group. So this is if you have an edge profile where like say you want to do an edge all the way around. This is the profile that you would use. Again, it's probably easier. We've usually just bought bits that were pre-built into Mozaik, way easier than trying to get something else. But also contact Mozaik help to see if there's other ones pre-built that you can use. They do have a lot pre-made. So that's basically it for the tool library. again, you can add copy groups, whatever. And this setup works the same as the last page. It's just on the outside edge instead of the inside. All right. The remake library and the remnant library are, kind of built into other parts of Mozaik. But if you wanted to see which parts you had to remake, you can hit this. It'll show you which parts. This would be more useful when you've already started cutting a job and you've lost some parts and you've marked them as a remake and you want to see them. That's where that would show up. The remnant library would be if you're squaring up your offcuts. You can look at the remnant library and you can see which remnants are, depending on how you manage your stock. Excuse me. Depending on how you manage your stock, you can check the remnant library and see if you want to cut any parts out of the remnants first. And you can also add the remnant to you can add new remnants. So if you have a bunch of sheets that are a certain size, you can add the remnant, update the shape, the size, the quantity, how many you have, and then you can delete the remnant. You can X out of there. We don't need to. You can also, here is where you'd select it from the library. So if you have one that you've saved, you click that and you drop it in. So then it'll cut from remnants first. If you go down here and you have this selected, if you don't, it'll just if you can have this if it helps the optimization, or don't use any remnants at all. Here you can also, this is where I usually do it. If I'm adding a remnant, I'll add it here and I'll say, okay, I got 5 that are 30 by 50 or whatever, and then I'll have it run that first. So this is the material menu. So you can add new materials here if you wanted to. You can delete the current material. If you have several, it'll show in this drop down. You can change the material to something else here. Again, I recommend all that be done mostly in Mozaik. Try to get your exports as clean as possible before you run it to the optimizer, otherwise you're going to run into issues. Here, I do use this sometimes if I'm trying to quickly run a part and I don't want to change that it has grain or doesn't have grain. You can add that it has grain, and then it'll try to follow whether like drawer sides will run lengthwise along the sheet. That's how that would work. Width trim would be how much is trimmed off the top and bottom edges and the side edges, the length trim. That's set up in the material library, which if you go here and you go here, it'll tell you width trim, length trim. You can do this in Mozaik as well. You don't have to do it here. We should do a quarter all the way around. This is the width and length. So say you have, this is helpful if you have a sheet that's, say you're running a pre-finished plywood or something and it's not actually an inch bigger, you just want to do it at 48 by 96. It's easier to update it here, and then in that case you can go into your library, material library, update pre-finished plywood as a smaller size. 49 by 97. So that's basically it for this page. Then you're going to move on to the parts tab. So under the parts tab, look, if you see any parts that are green, this indicates that it's got operations on both sides and or it's a back if you're using qualified tenon. Mozaik will not automatically flip the backs even if there's no operations on that side. So there's a few ways you can flip all the backs if you have qualified tenon. You can wait. You can do it at this point. You can click here and then you can go all the unfinished backs. See how they're all green? And you can hold shift and click the bottom one and hit flip parts. That'll flip them all. Now they're no longer green. I'm going to undo that. Anything else that's green? I don't think I have any other flip side parts, but sometimes if you have a back with drilling in it, like shelf pin drilling, you may have a double-sided part. So I'll end up manually going in the optimizer, flipping it over to the other side. I'll just show you. So you can double click it, brings up this menu here, and say you have a certain operation that you want to flip to the other side. For instance, through drilled shelf pin holes. you can flip the sheet over here or flip the part over, and you can select whatever you want to flip. And then I'll usually change it to thicker than the material, so 0.75 or whatever, because it's a shelf pin, it'll usually be like 1/2 inch. And then I will right click on the part, move to opposite face. Then I'll flip the part over on the machine. If it's going perfectly, everything should be, nothing should be green, I should say. So now another way to flip all these parts over is to go right to the Optimize tab, optimize it, and then flip it. That's how I usually do it. But that would work that way. So here, if you have any parts that you're trying to sort through, this is where you're probably best to do it. Say for instance you've rerun a cabinet, but you only need certain parts off it. You can delete, so you select that and just hit the delete button on your keyboard, and or delete part here. You can delete a bunch. So as you can see, it doesn't look like it's changing, but I'm deleting a bunch of parts here. And then say I just want the finished ends, I'll delete all the rest, and then I'll delete all the rest down here, and I'll keep the finished ends. That's how you would isolate certain parts. And then you go to the Optimize tab and you optimize it. So close out of there. I don't want to save anything because I want to rerun it. So cut list. I'm going to rerun everything. Optimize again. Overwrite with new parts, like I said before. And the window pops up. So we got parts. Now I'm going to go to the Optimize tab. So if you set up your machine correctly and you set it as default, it will show up right here automatically, your machine. Here's your tool sets that you set up in the libraries. So we got HC cabinets and doors, the ones that we use the most. This is part spacing, so if you update this, it will usually stay the same every time you open it. So if you set it to 1 inch, because you want, say you want a gap between so the parts don't move too much, you can set it to 1 inch, but the next time you open it, it will stay the same. 7/16 is what we use usually, 9 times out of 10. And optimization, quality, so this is if you want to, it'll do nesting a little bit better if you select best here, but it does take more time, like maybe an extra minute or something like that, depending on the speed of your computer. This one's the fastest and most, I guess that's why they say recommended. As you can see, slow. Estimate would be if you just want like something super fast, but I mean this one goes pretty quick, so it's not really worth selecting that. So here, sequence by cabinet number. So if you want the machine to cut out all of cabinet 1, or at least try to cut out all of cabinet 1, and then sheet 2 will be, the rest of cabinet 1 and starting to cut cabinet 2. Sheet 3 will be, cabinet 3, and it will try to cut each cabinet in sequence. This is what you would select. We do use this quite often because our shop's really small, so we like to have a full cabinet cut, assemble, edge it, get it out right away, so that's not sitting in our shop blocking off the doorways and stuff. So we use that quite a bit. Sequence flip side parts first. This would be used if you have flip side machining on something that you wanted to do only the dowel drilling on the beginning and get that all over with. You can select the flip side parts first. Batch optimizing will give you, it will let you optimize multiple materials at once. So if you're, you can optimize, MDF and the other material at the same time. We do it individually because we just like to keep more control over it, but you can use this as well. Optimize selected parts only. You can select this if you want to optimize only the selected parts that are in, like say you went over here and you selected, I only want this, this, and this. That works also if you're trying to isolate certain parts. You just select the parts you want, you hit optimize, you select only those parts, and you hit optimize, and it'll just run those ones. So that's kind of handy as well. Now, another thing too, so that's all this here, and optimize is what you hit to make it go for it, and it'll start doing its calculating and whatnot. Choose patterns if you really want to select. You want a lot of control over the methods in which it yields. We don't do that because it's a little tedious, so we just let it figure itself out. We figure the computer should be smarter than we are. Cutout options, you can bring this up on the sheets individually as well. So, but if you this will be like your default setup of how you do cutout passes and stuff. So you can do climb feed, conventional feed. You can arc the corners, which we don't really do. Ramp in, helical in, out. Those are just different type of plunge passes. Linear or zigzag plunging. Linear seems fine for us. This is small part handling. Here's where we do the whole thing in 2 passes. So full sheet skin will give you it'll skin the whole sheet, cut it as thin as you select right here. And then it'll go back and cut the small pieces first. We lose less parts that way, and much better dust collection, certainly for our setup. This would be if you want to pocket out small waste areas, which seems kind of like unnecessary tool wear if you ask me, but whatever. Here you can use tabs if you want to, and then you can have like cutouts manually. If you want to not have the machine go and cut out the tabs after, you can cut them out manually with a knife or whatever. Dado options, so this will give you like run past. Do you want to run past for the dado corners? Do you want to do a T-bone, which is weird? And then there's a dog bone, which is kind of handy sometimes. So let's go on to let's go to that parts tab, and then we will optimize this, delete, and then it's going to run through the optimizing. So got 13 sheets worth here. So this is where if you have several materials, you can jump through the materials in this box. Here will be your remake bin. So say it won't let me do it unless I run the G code for it, but say you've ran a sheet and you've lost like this part specifically. That would mean that you can select it to be in the remake bin, so then at the end of the job, if you have a sheet like this where you can fit it, you can now drop it back on. Probably better for drawer parts and stuff like that. So the other way that I was showing you, so you can flip your parts, you can see there's a few that are green here. If you go to your flip parts here and you're on view all patterns right here, so say if I click this sheet, if you just flip parts here, it'll flip the parts for this sheet. And then if you hit view all patterns and view all your sheets, if you click flip parts now, it'll flip it for all the sheets. So every sheet will be flipped. That's the fastest way to flip all your backs over. Be a little careful that you're not flipping certain parts that now it's flipped over, but it's overlapping another part, because Mozaik won't be smart enough to know that. That'd be for like corner cabinets and stuff like that. So view parts list, if you want to view all the parts that you're working with here, you can see like sheet 1 part 18, sheet 2 part 27, blah blah blah. View unplaced parts. If Mozaik's ran a nest and it doesn't fit all the parts on, it'll have any parts that don't fit, say bigger than the sheet or whatever, in this list. So from this menu, you can also add a sheet. So you can add a sheet, and if you go view all patterns, you can view the sheet that you've added. Say you have a part that you want to add manually. So I'm going to add, say, a toe kick at 4 3/4 by 96. So I have a toe kick, and I want to add it to that last sheet. You see it's added it to unplaced parts. You can now drag it and drop it in. From this point, you can manually move it around. If you want to set it where it's going to be permanently, you can either bump it left and down, so bump it into the bottom corner, or you can manually place it by setting the position. So you can set this at 0.25 and 0.25. So that's from the bottom corner. You can rotate it. Obviously we don't want to do that. You can edit the shape of the part. So if you want to add points, change the shape however you want. You can delete the part, and then this is where you would move it to remake bin. Like I said, it's not going to let me do it because the G code hasn't been run, so it's confident that it hasn't been cut yet. So I'm going to run the G code for it. So if you're doing this individually, like say I want to run the G code for the whole job, you go view all patterns. So now again, it's going to do it for every sheet, generate G code, all sheets, and you can also do multiple materials. So you could run it for like MDF and the melamine. You can do flip sheet programs. So that'll be how you would do your dowel drilling and all that. Again, we don't use that. Individual flip part programs. So if you wanted to try, if you had like a point-to-point machine and you want to run your individual flipped parts on separate G code, you can have this checked off. That's something you might want to set up with training or something like that to help that move along. Again, try your best not to have flip side parts. It makes it way simpler, way simpler. But yeah, so that's how you would run the G code. I'm going to run the G code for all the sheets. So now it's ran the G code. Where does it put the G code? You indicate that by your preferences. So you select where you want your G code to go. I have it going in my OneDrive. So I'll just do that one more time. Settings, preferences. This is where the G code goes. You can set it right here. Your data, and this is your directories for everything. So again, if you're on a OneDrive and you want everything to be connected together, you would set your folder as this. If you're on a single computer, it's not really relevant that much, so it's not a big deal. Your texture directory, images, and you can have that all connected to Mozaik itself. Okay, so we've now run the G code. If you're looking for the G code and you're trying to find it, you go to your Mozaik folder, jobs. This one is called Arpin Leonardo. Then you have your G code folder, and it's separated into the material, and then you have all your sheets. So you have sheet 1, sheet 1, run 2. If I run the G code again, it's going to say sheet 1, run 2. And that's what the S and R stand for. So that's the file that you're going to use to load into your controller. So now if I have this part and I want to move it to the remake bin, it's now moved it to the remake bin. Say I have several parts. Maybe I have this one. And you're using the right click on your mouse to bring up this box. Move to remake. And as you can see, if you hit the remake bin, you now have a few parts that you have to add in. So that's where you go view all patterns. I want to add another sheet, and I need to drag this guy in and this guy because it's goofed up on me. Now, if you want to edit the sheet, or if you want this to be optimized again, so now you have a bunch of parts you just dragged in here. You hit edit sheet, re-optimize sheet. Are you sure you want to re-optimize? Yes. And then it'll re-optimize it. Now, because that part's so big, it's not going to run it. Where is it? Oh, remake bin. Yeah, because this part's so awkwardly sized, it's throwing an error for that. We can fix that by deleting this weird point, and then edit sheet, re-optimize sheet, yes. So it'll re-optimize it however you want. Now, this isn't really a smart way to use the waste material. So, I mean, of course, you could click there with the left click and then it'll pop up with this menu. You can cut the remnant, save it to the remnant library. Then you can also right click, remove the remnant. So that being said, like I said, this is kind of a wasteful way to run this. If you go to patterns up here and you move the pattern down, it'll move it all the way down. That way you're getting much better yield off of this sheet. So that's how you sort of manage your parts. View all patterns again. Is there anything else I need to go through? You go through your parts. So you've ran all the G code for everything, but say you're individually cutting each one, and you have something you want to change. So you've ran this one, but you go, oh, I can fit my toe kick here. If you go to, let's just go to that toe kick and we'll delete it off of there. Oh, we haven't run the G code for this sheet yet. Let's remove it and then re-add it. So go back here and then say I have this piece here and I want to add my toe kick to the bottom. So I've got enough space there, or at least it appears that way. We'll just assume there's enough space. Bump left and down. In this case, it might actually cut into it, but for the sake of the video, I'm not going to worry about that. If you wanted to make 100% sure, you could edit your sheet, re-optimize the sheet, see if it'll do it. Yeah, it's going to remove some parts because it's not going to fit. But that's okay. So you've changed something on there. You need to rerun the G code for it. You're viewing the sheet individually and not all the sheets like this. You hit generate G code, calculate. Here's how you can also run a certain toolpath. Say now you've ran a sheet and something happened, you had to stop it, but you don't want to lose the material that you have already drilled holes in. But now you don't have to do the drilling because it did all the drilling. You can select not to run all the tools and only to run the tools that you select. So you can run, you can run the pocket separately, and then you would hit G code. So you'd run the G code. You can see sheet 13, tool 2, run 2. So I ran it twice, and this is tool 2. And then if I do this one, then I can hit G code, and this is tool 4. So now it'll do the cutout pass. So you can run each part individually. Calculate, edit path. You can edit the cutout here as well if you want to have more control over that. Same window as the other one. You can move the tool paths up and down. So if you wanted to drill first, you really should have this set up in the tool libraries, so you don't have to mess with this. But there is more control you can do. If you select all tools, it'll just G-code everything, and it'll give you the option to do those two little check boxes again. You can also select a different tool set if you want to use a different tool set, and you can also select a different post-processor. So that's how you would run it individually. That's basically it for that. Now the G-code folder here, I don't use this one too much. I just go back and forth between the patterns and the labels tab. So if you do use this one, let me know in the comments what you use it for, just out of curiosity. I know there's a barcode thing here, but we tried to set it up, it didn't work. So let me know in the comments if you do have a use for this G-code folder. I know there is some things you can use it for, but most of it's done in the patterns tab and the labels tab. If you pay for the label upgrade, you have this tab here set up. So here what you would do is you would set up your labels in Mozaik. We have one set up already. So you would select your label, you set up your printer. This is probably a whole nother video to go into. I'm not going to do this now, but you set up your label here and you apply, save your printer. Now from this window, you can select, say, a part individually. You can print this label individually. I'm not going to print anything. I'm just going to hit view label just so you can see what our labels look like. So it will print all the labels like this. It gives you the job name, what type of cabinet it is, the edging setup. This is also the edging location here. It gives you where it is on the sheet, and that's pretty much it. You can print it there. You can print all the labels for the sheet. We don't use this option because we like to use this tab to know which sheets we cut already. So if we've printed the labels, the sheet will actually turn green like this, where you hit mark complete. And that way, if you hit view all patterns, you'll notice that you've cut sheet 13 already. So that's how we track which sheets we cut, by hitting print all. And you don't, careful not to hit view cut, print all when you're viewing all the patterns, because it's going to print all the labels for every sheet, and then you got to like scramble to stop the printer from printing a billion labels, which, you know, of course you could use them, but then you got to sort through which ones are which, and then all your, you know, it's kind of a pain. We don't do that. So that's the labels tab. It's pretty straightforward. You can view the label, print one label, print all the labels, and then go from there. Switch from materials here, same as the patterns tab, and then that's basically it. The summary gives you an idea of how much yield you're getting off each sheet, how many parts you're getting, the quantity of sheets, and so on. But that's pretty much it for that. So the last thing I want to go through is the units. So if you're going to change your units from inches to millimeters, it's set up here. You can also round it to the 32nd, 64th, fractions or decimals. So that's basically how that works. And I think that's basically it for all the optimizer. Can't think of anything else I'm missing here. If you have any questions, leave it in the comments and we'll do our best to try and answer for you. Sorry for this super long video, but at least it's giving you lots of experience on how to use the optimizer. Thanks for watching. See ya.